Alright, welcome back. I have another problem. This is QID .1192, or P1192, excuse me. And it's under thermal hydraulics as a topic. So, first thing we do when we solve problems is we look at numbers. 3,400 megawatts. Probably going to have to turn that into BTUs per hour, but maybe not. I don't know. Delta T of 60 degrees Fahrenheit. 1.4 times 10 to the 8th pounds mass an hour. Those are my normal units, so that looks good. 63.6 degrees Fahrenheit, that looks good. 0 degrees Fahrenheit. Alright, now we read the question. The reactor is producing 3,400 megawatts of thermal output with a reactor vessel differential temperature delta T of 60 degrees Fahrenheit and a reactor vessel mass flow rate of 1.4 times 10 to the 8 pounds mass per hour. If the core delta T is 63.6 degrees Fahrenheit, what is the core bypass flow rate, mass flow rate? And we're assuming that bypass flow delta T equals 0 degrees Fahrenheit. Okay, there's a couple of different ways to solve this problem. If you happen to remember that mass flow rate bypass is about 6% of total vessel flow, what does that give you, right? 1.4 times 10 to the 8 pounds mass per hour times 0.06. It's going to be 1.4 E8 times 0.06. That's 8.4 times 10 to the 6. And look at that. I got that exactly. But that's a trap. So don't just go remembering that old Jeff told you 6% of mass flow rate through the vessel is mass flow rate of the bypass. So that's a distractor right there. I wanted to point that out to you. To find the real answer, what we do is we understand this concept right here. This is a big concept I want you to understand. Mass flow rate of the vessel is going to be equal to mass flow rate of the core plus mass flow rate of the bypass flow. Alright, so we got to find mass flow rate of the core. And then we're going to find mass flow rate of the bypass using this equation right here. So the Q dot of the vessel is going to equal the Q dot of the core. The Q dot of a bypass flow was 0 because assume bypass flow delta T equals 0 degrees, right? So we know that Q dot of the vessel is going to equal to Q dot of the core plus Q dot of the bypass, but that's going to be equal to 0. I should have wrote it that way, sorry. Alright. So Q dot of the vessel is going to be equal to mass flow rate of the vessel, C sub P, times the delta T of the vessel, which was given. That's going to be equal to mass flow rate of the core times C sub P times delta T of the core. Alright, so mass flow rate of the core is going to equal to mass flow rate of the vessel, C sub P, delta T of the vessel, divided by C sub P times delta T of the core. Alright, so we know that C sub P is going to be approximately equal, very, very close. So I'm going to go ahead and say that those are equal. and these two will cancel each other out. So now we got a mass flow rate of the core equal to the mass flow rate of the vessel, 1.4 times 10 to the 8th pounds mass per hour times delta T of the vessel. If core delta T is 63.6, vessel delta T, vessel differential temperature of 60 degrees. So I got 60 degrees Fahrenheit, delta T of the vessel, and 63.6 degrees Fahrenheit, delta T of the core. So use our calculator and get 1.4 times 10 to the 8th times 60 degrees divided by 63.6 degrees. It's going to be 1.321 times 10 to the 8th. 1.321 times 10 to the 8th pounds mass per hour, because the degrees Fahrenheit are both going to cancel each other out. Alright, so remember, mass flow rate of the vessel is going to be mass flow rate of the core plus mass flow rate of the bypass. So therefore, mass flow rate of the bypass is going to equal mass flow rate of the vessel minus mass flow rate of the core. Easy way to do it is just leave the last number you got, which was 1.32 times 10 to the 8th, and subtract 1.4 times 10 to the 8th. That'll get you 7.92 times 10 to the 6th. Which is very close to 6%. So I didn't lie to you when I said that in class, because it's 7.92, got an exact number. So you got exactly 6%, and that is approximately 6%. You see those numbers are very close. These two numbers times 10 to the 8th should tell you right there that those two numbers aren't very good. Those aren't an accurate description of mass flow rate of the bypass. So I hope you learned something. Don't just go jumping on stuff like this to make the problem easier. Actually, do your due diligence. Get the right answer. All right, thank you.